Hi, the internet is a wealth of knowledge, but how do we leverage that knowledge programmatically? Sometimes services make APIs available for us to export information from their platforms, but other times more ingenuity is required. Web crawlers, no different from Google's Googlebot, scour the web, downloading relevant information. Join us for this webinar. We'll discuss Sparkler, how it works, and how we deploy it at scale. Hi, welcome to this week's Research Platforms webinar, which is Crawling the Web Like a Boss. Who are we? We are Research Platforms and we're based in the UK. We develop bespoke data processing solutions for the science and research areas and also for business specific platforms as well. We specialize generally in open source software, not completely, but most of the stuff we do is business friendly, Apache licensed data processing goodness. We currently work with organizations like NASA, US government, UK government, and an American-based Cancer Research Institute to build cool data processing platforms to allow users to get to what they're interested in without having to worry about the nuts and bolts that hold it all together. So what we're going to look at today, we're looking at web crawling, and so we're just going to do a bit of background into what web crawling is. It's pretty much existed since the dawn of the internet. Search engines are the most obvious case. Google doesn't work by accident. It has the Googlebot that goes out and crawls all these websites, aggregates them, extracts textual information and sentiment from them, and then helps rank those sites accordingly. Other open access projects include the Internet Archive and Common Crawl. They're both open repositories of crawl data. But crawling has got a lot harder as the internet has generally got more complex with server-side rendering, various bits of different plugins that don't render text information without actually sticking it into a browser. It's a tricky business these days. So how can businesses make use of Sparkler? And that's a very good question. And some of the ways that businesses can make use of crawl platforms in general is internal or specialized search engines, competitor analysis, keeping track on an automated way about what your competitors are doing. You could do news alerts and updates. Text analytics and sentiment analysis is often a common case, and also just more simplistic things like HTML validation. So what about Sparkler and what is Sparkler? And so it was started in 2016. It's by the USC Information Retrieval and Data Science Group. The founding developers were Dhamay Gowda, Karanjit Singh, and Chris Mattman, and it was inspired by Apache Nutch, but based on Apache Spark, and so leveraging more modern technologies. How does it work? So Sparkler leverages the Spark RDD for data processing, which allows for greater scalability as you can chuck your Sparkler job directly into a Spark cluster and allow it to scale horizontally. It uses Solr for data storage and retrieval, so pretty standard indexing platform there. It renders the JavaScript on the server side for text extraction if you need it to, and uses various crawling features which reduce the chances of you getting detected, because some sites don't like it to be crawled. Allows you to mimic human interaction with different click frequency or the way the inputs are dealt with, and not overload the target servers with requests, because you don't want to be the bad person in the internet and stick too many requests down the target server and make it fall over. So how can we deploy Sparkler at scale? What we're looking at here in this tutorial is how to actually, deploy Sparkler and leverage it, in a way that's not just a single server instance. And so you could do it manually. There's nothing stopping you doing that. Or in this case, we're going to use the power and flexibility of Kubernetes to help you distribute the crawler across a Kubernetes cluster, run Solar Cloud for a more scalable Solar deployment, and generally make it more sort of production ready. So with all that being said, let's get on. Okay, so as you can see, we're on the Google Cloud Platform user interface. It's, what we're trying to do here is deploy Sparkler using Kubernetes. So we're going to go into the Kubernetes engine. It's very straightforward to set up a Kubernetes cluster using Google Cloud. So we're going to click Create Cluster. Then from there, we're then going to create a standard cluster. By default, it's got 3 nodes. Each node is very low powered. If you're using the free trial, then it's not going to cost you anything at all. So that's always a good start. Select where you want to deploy it. And in our case, because I'm based in the UK, we're going to select Europe West. And then if we just scroll down, you can see there's the number of nodes, the different CPU types. So you can, of course, choose a more powerful deployment. There's nothing stopping you doing so. And you just go and choose one from the list. On the left, you can also see a bunch of different Kubernetes clusters. By default, they give you some good ideas to get started. So if you're doing something that was more RAM intensive, or certainly GPU style for machine learning, that type of thing, you can set up a dedicated cluster for different purposes. So I'm going to click the Go button. Then it will spin for a while. Basically, under the hood, it's spinning up 3 Google Compute servers, and it's going to then register them with the Kubernetes controller, which you don't even see. This is the wonders of Google Cloud. And so when it's finished spinning up, you'll have the 3 servers and then the ability to be able to interact with them using kubectl. So as a refresh, you can see that it's just started populating more details there. And you can see the total memory and the 3 vCPUs that it's trying to spin up. And we'll just wait for it to finish. Doesn't take long. If I just hit refresh again, let's just see, it's nearly there. Oh, there we go. So the green ticks turned up. So that means your Kubernetes cluster is now up and running. That was pretty straightforward. And then from there, we're then going to configure the services. So if I just click on the cluster, you can see the details in the window. Just to prove what we've spun up. So you've got a Kubernetes cluster, 3 nodes in Europe West. You've got an endpoint IP address and various other bits and pieces that you can configure. If you want to scale up your cluster, you can do so from here. If you want to update Kubernetes, you can do so from here. And manage it as you see fit. Similarly, once you've finished, you can obviously tear it down from this place as well. So this is the control room for all things Kubernetes. As I scroll down, you can see the node pools. So in the node pools, you've got the different details about the different nodes you've got stood up. Of course, you could have like more than one node type as well. So you could have some standard, some GPU nodes, that type of thing. And as I click through, you can see it's empty at the moment. Obviously we haven't deployed anything to the platform. So as I click through the different windows that are available inside the Kubernetes engine, you can see there's nothing provisioned. All the stuff is available in the command line as well, but this is a nice way for us to be able to visualize it in this tutorial. One of the interesting things about this tutorial is, whilst I'm going to use a command line, it's all through the browser. So literally I've got nothing installed on my laptop. So you could do this entire thing, on a Chromebook or something low powered. There's no requirements to install anything. And I've just run the Google console, and you can see it's popped up at the bottom. And then the command that it's populated for me just authenticates against that cluster. So now that's run, I should then be able to ask Kubernetes for various things and it tell me the answer. So if I do kubectl get nodes, you can see when that returns, it should tell me that there's 3 nodes available. They're all up and running and ready. So what you see in kubectl should reflect what's available in the dashboard, the Google Cloud dashboard as well. So they're both telling you the same thing. You can use the console if you feel confident in doing so, or you can use the dashboard for administration purposes if you want to. So what I've done now is open the Google Cloud shell in its own window, and so still within my browser. It's still web-based, but it's now running its own window, so I can see stuff better. Next, I'm going to run kubectl get pods just to show that there's nothing in there. This is a completely clean Kubernetes deployment. We haven't got Helm installed by default, so we're going to install Helm. If you don't know what Helm is, it's like an application deployer manager for Kubernetes, and you can create what are known as Helm charts that allow you to deploy things like Sparkler to Kubernetes, just tweaking a few of the configuration variables if you have to, which can spin up like multi-service deployments. And they've got like an online repository, so you can do that from the web. There's a few interesting quirks with Helm on GKE at the moment, and so we need to just run a couple of init commands just to make it talk to the latest Kubernetes install. The link for the fix is in the description, but we'll just do Helm init. So, that's Helm installed. So now technically if I wanted to deploy Spark or something, you can, do Helm install Spark. If I want to install Sparkler, there's, by the time this is finished, there's going to be a Helm chart for Sparkler. So you can do Helm install Sparkler, that type of thing. So now if we look in the deploy folder that I've created, I've split up a deployment YAML into various sections so we can just walk through it. We could use the Helm chart, but for this one, I'm just going to use a simple Helm Kubernetes deployment YAML script. So we're going to do kubectl apply init.yaml. And you can see there it's asked for persistent volume claims, and it's created some config maps. So if I do kubectl get PVC, you'll now see that there's 3 persistent volume claims that have been asked for, they are storage pools for you to be able to store stuff, and there's also the config maps as well. So the nice thing about GK is if you ask for persistent volume claims, it will provision the persistent volumes for you, so you don't actually have to go and do anything. If you did this manually, you'd have to define folders and all that type of stuff. But you can see now inside the dashboard, there's now Solr config, Zookeeper config, and a couple of different persistent volumes, and you can click via the GUI through all these, and they'll show you the same stuff as it would show you on the command line, but we can see the stuff easier. So you can see where the config values come from. You've got Zookeeper data directories and catalog directories and that type of stuff. So config maps allow you to inject environment variables into your containers, and obviously persistent volumes allow for data to be stored should you tear down a pod, or should you restart for any reason. It means that your data will be persisted, assuming that you write to that volume. So with that deployed, we're now going to have a quick look at the YAML itself. So you can see that the YAML allows for simple claims to be made. You define your persistent volumes, you define your config maps, and from there, I'll just refresh this because it's had a slight issue. The cloud editor has some fun and games if you accidentally copy and paste. I don't know why. But you can see the YAML is pretty simple and just defines various attributes for the deployment. And so these are persistent volumes and config maps, and then we're going to get on to different Kubernetes bits and pieces in a second. So now we're going to do kube control apply -f, which is file, and then we're going to deploy the ss.yaml, which is stateful sets. And so we deployed 2 stateful sets, which is Solr and Zookeeper. And if I do kube control get stateful sets, you can see that there's 2 stateful sets that return there. The idea with stateful sets is that they will give you a set of pods that retain state as they scale. You've got the ability in Kubernetes to scale massively. So by default, we've launched one of each. But Solr, for our requirements, is configured in Solr Cloud, so you could have more. Similarly, Zookeeper, for an effective quorum, you want to have 3. So you should deploy 3 Zookeepers onto separate nodes as a bare minimum. And then also, 1 Solr to get you going is absolutely fine, but as your crawl scales, or as your requirements for querying the data that's bringing back scales, of course you can then scale Solr Cloud as well to better distribute the queries over the network. So if I just flip back, so you can see if I do kube control get pods now, and the pods are the individual Docker containers running, and so you can see I've got one of Solr SS0 and Zookeeper SS0. And if I describe the Solr SS0 pod, if I spell it right, so kube control describe pod Solr SS0, you can see that it dumps out an awful lot of information about that pod, what condition it's in, IP addresses, network, all that type of stuff. And so all that is then available to you should you require it. Then we're going to do kube control get pods again, and then kube control apply -f sparkler.yaml. This will then deploy the Sparkler pods, as obviously this is a Sparkler demo. So you can see it's currently in container creating state, which means it's got to download the Sparkler image from wherever, put it onto the box, and then start the Docker containers itself. So it takes a few seconds. It's not instant on the first run. If it's cached up in future, it would pretty much start it without any issues, without any lag. but the first run normally takes a couple of seconds. We get pods again, still creating. We'll get there in a minute. Oop. Sorry. If your pod gets stuck for any reason, if you do kube control describe pod, it will also tell you what state it's in. So, it'll tell you whether it's up and running, if it's got any issues up and running. You can see the status here is running. So if we do get pods now, you'll see they're all running. It would have told you that it's in the middle of deploying it and this is what it's working on. We've started Sparkler as a deployment. So you can see that we've got a desired 3, current 3, up-to-date 3, and available 3. The cool thing, of course, with Kubernetes is your ability to be able to scale up and down without having to change a great deal. Kubernetes deployments are designed exactly for that. So what I can do is, tell Kubernetes to launch more versions of Sparkler. If you want to do massive parallel processing, crawl of various different websites, you can then do like kube control scale Sparkler and then also obviously the amount that you want to scale by. So kube control scale Sparkler replicas. This is the actual amount. You can either scale by the amount of new ones you want, or you can scale and say, I want 5. Oop. So if I get it right, so scale, and then we're trying to scale a deployment. So if I just type deployment in there, scale Sparkler, there you go. So you can see Sparkler has been scaled, and now it's got 5 that it's trying to launch. So if we do get pods, you'll then see, there's 2 more that it's trying to create. Because Docker containers aren't supposed to save state, if you then shrunk it back down, you need to design your containers in a way that accepts the failure of 2 containers effectively, because it won't do anything particularly gracefully. It'll just terminate your containers. But that's generally not a problem for something like Sparkler, where you can design for failure. On this one, in this deployment, we've not defined a load balancer. On GKE, really, you should define a load balancer to be able to get access to it. But what we've done is asked for the external IP, which it's just returned into the console. And then if we just have a look at the stateful set YAML, you can see at the bottom, we've got this Solr services. So services in Kubernetes are what expose different aspects to either the internal Kubernetes network or the external user-facing network. And so you could either have a node port or a load balancer are the common ones. If you're doing stuff like in Minikube, you'd use node port. If you're doing stuff on GKE or another cloud Kubernetes service, you're probably going to use a load balancer. But I just haven't changed this one. So here we go. So you can see how we've now got a working Solr dashboard. And so if I just click through into collections, you'll see also we haven't got any collections defined. And so what we're going to do is create a collection, but we're going to do it on the command line. So if I do kube control exec minus IT, which is interactive, and then I will copy the Solr SS0 pod and go and ask for a bash shell. So then you can see now that I'm the Solr user and I'm on the Solr SS0 pod. And so if I do, if I go to the wiki, you can see how we've got a command there to create a collection. So if I copy that out, and then go back to where I was, and then paste that in. So this is running the Solr Create collection. There is a crawlDB schema that's been initialized with the kube control spawning. So the Solr instance knows what the crawlDB schema is. That will happen automatically. And from there, you can now see that we've got a collection that's using the crawlDB config. And so if I just click through, I should then be able to query it. So it'll have nothing in it, of course. There we go. But I've now been able to spin up a Solr instance that's got the crawlDB database in it. And so I can then query that. So if I just exit out of there, if we're going to start crawling the web, the first thing that we need to do is create a list of sites that Sparkler needs to crawl. So as I said earlier, there's obviously a whole bunch of different ways to be able to use Sparkler for business. And so either competitor analysis or tracking of different attributes, stuff that's publicly available, crawling of news sites. There's a whole realm of different ways to be able to do it. This one, we're going to crawl Tesco looking for prawns. So I've copied out the URL from the Tesco search. And so if we do Java jar, Sparkler app, then if we inject, and then we're going to use a file, you could just inject single URLs, but you could load this file up with a whole bunch of different URLs and tell it to look at. So you can see here that I've forgotten to reference the crawlDB Solr. By default, it'll look at localhost, but of course we're not running locally, we're running distributed scale up. So if I go back and stick in the crawlDB, which is the Zookeeper endpoint, and execute, you can see how it's now generated a record which is unfetched, but the Tesco URL and the grocery search. So what we're going to do is then take that, and then we're going to stick in the job ID that returned, which is this one right here. Paste that, and then hit the go button again. And what will now happen is that it will start crawling. So it will start there and start spidering its way out. And so it will run once, and then we'll go back to the Solr query window. You can see now that there's a whole bunch more unfetched URLs in there from the first attempt. So it's gone and had a look at the first layer of links that's available inside the inside that first iteration of the URL, and return them and put them in the index ready for spidering. And so this is how obviously spiders work, and they will work their way outwards. And we're going to go from there. So what we'll do now is go back to actually, let's see if we can filter this. So if we do status equals fetched, you can see that so far no records have been returned. It hasn't actually fetched anything. It's gone and staged up a bunch of URLs. So we're going to go back. We're going to then tell it, we're going to run a few iterations on it, which means loop through everything a few times, come back, start with all the unfetched ones again, and so on and so on, and work your way out. And we're going to leave that one to run. And so what you can see here is the terminal is now working its way through the different links that are available in each website. It will go and request that website, download the text, download header information, all sorts of metadata, MIME types, that type of thing, and return them all for further analysis. What you could do is, if you're looking for something specific, is write a plugin that can either constrain what it's looking for or enhance what it's looking for. there's plugins available that if you wanted to do server-side rendering, because the website happens to be JavaScript only and doesn't render anything without it, you can tell it to render the website on the server and display that textual information that's available. There's a whole bunch of cool stuff that you can do with browsers, and certainly these days with virtual physical browsers under the hood, like headless browsers. So we're going to speed this up, and you can see it doing its thing. If you're interested in contributing and helping out with Sparkler, it's a great project to work on. There's a very friendly team from the USC data science group who are willing to help mentor you and help engage in further development. So swing by the Git repo and say hello. There's also a Slack channel that you can get invited to. But it's Apache licensed and very friendly and under reasonable development. So it would be good to be able to drive this forward. So if you have an interest in web crawling and want to do something that's a bit different, I really suggest that you take a look at Sparkler. I think it'll be well worth it. And so what we're going to do whilst that's running is just flip back across. So it doesn't have to finish. You can start having a look at Solr from the start. So you can see this one's been fetched, and you can see all the data that's been brought back. And if I just flick through these, then you can see the extracted text, which is obviously anything text-based that's been brought back that matches from the website that's been matched. And so you can then post-process that to be able to extract textual information from the site. Oops, sorry, let's just run that again. If I return a few more records this time, and there we go. So, you can see how we've got the index time when it was last updated. So obviously you can return, if you're doing basket analysis of competitors and stuff, you can return to keep asking what the cost of prawns is. You don't have to do it once. If you want to monitor Tesco's prawn costs over time, if you're trying to undercut them on the prawn front, which I know every business is trying to do, this is how you can go back and double check stuff. But you can also say, send me things back that were obviously done within different times, different parsers from Tika. You can do it on MIME type. You can see where stuff is coming from in terms of Amazon Web Services, what web server, that type of thing. So, there's an awful lot of metadata alongside what's been extracted from the crawl in terms of text data itself as well. So I'm going to try and on the fly write a bit of a Solr query. So I'm a bit rusty with Solr. So here we go. So status, and then we're going to do fetched. Oh, it's capitals, isn't it? So if I do fetched, there we go. So this is everything that's been fetched. Of course, the crawl's still happening in the back end. So there'll be stuff that's unfetched. When it finishes this stuff, it's unfetched. And then we want to do stuff that's been fetched, but where the text, the extracted text, contains prawn information, I think. So if we do status fetched and extracted text has the word prawn in there, that's wildcarded, so it's not just equals prawn. Nope, what have I done wrong? I can't spell. And so extracted text, and then you can now return all these records that have prawn in, but there's a lot of data there. So if we then do field list is just extracted text, and you can see how we've now just narrowed this down to the records that contain the word prawn in the extracted text and have been fetched. Let's show a few more. Because basically what it's returning is JSON, we can now go and use this in a bunch of different programs, and Solr has a very flexible API that you can just call and extract the data from. So if you wanted to leverage this inside a Python app or something like that, it'd be really simple too. You just call Solr and then go and crunch the JSON into a dict or whatever. But these are the records which are returning information about prawns. So if you wanted to then do sentiment analysis or basket analysis or that type of stuff, you then go and use your programming language of choice to then go and extract this data, extrapolate the data, and convert it into something that's a bit more, that's designed for your use case. And because it's a search index, Solr obviously is a search index, it will allow you to scale and stick in literally millions of records and continue this process without having to do a great deal. If you start to see slowdown, you can add more Solr nodes. If you need faster crawling or more distributed crawling, you can add more Sparkler nodes. You can deploy Sparkler directly into a working Spark cluster. The options and the flexibility is endless, and obviously we've already discussed the plugins as well. So if you want to be able to deploy it with a specific plugin that's not looking for prawns but is doing something more useful, then that's perfectly doable. There's some great plugins in the repo, and I will point you to them when we get back to the slides in a minute. So I hope that demo, that little introduction, has given you a good intro and a bit of insight into how Sparkler works on Kubernetes and how you can scale this stuff up. And we'll go back to the presentation. So hopefully that gave you a good idea about how Sparkler can be deployed. We'll do a further webinar in the near future about how to deploy it directly against Spark, so then you can run it in the Spark cluster. But this gives you a good idea about how to run multiple instances against a Kubernetes cluster. So one of the things that we were talking about in there was the plugins. So how can I extend Sparkler? If you have a specific use case, OSGI plugins are integral to the platform. You can build any number of plugins against it. So there are a bunch of examples in the source code. Existing examples include a couple of fetchers for JavaScript rendering, HTML rendering, and then also there's URL filters as well. So if you're crawling a whole bunch of websites and you don't want it to if you don't want it to crawl anywhere outside of the primary domain, or if you want to be able to filter the domains it does crawl via regex, there's a couple of examples in there, but of course you can then take these and extend them further. So you could have plugins for different MIME types, or a whole bunch of different stuff. So you can extend the plugins. There's a template there which gives you a getting started guide. It's Maven build, so as long as you've got a Java build chain and Maven installed, then you can get going with running more Sparkler plugins to fit your own use cases. Or you can come and ask developers, and we can work together to help create a new plugin for you. If you're an open source developer, if you're interested in contributing to open source, how do you contribute to its development? Swing by, say hello. You can come to the Git repo and say hello there. There's a Sparkler channel on the uscdatascience.slack.com. Check out the issues in the Sparkler repo. You can obviously You can obviously fix existing issues. You can file new feature requests, submit pull requests for new features. It's a good environment to work in. If you want to work on documentation, there's a whole bunch of documentation stuff you can work on. Clearly, there's also a whole bunch of deployment strategies and that type of thing that's available for people to contribute to and help improve, to make the deployment easier for people that want to get going with Sparkler. So there's a whole range of ways that you can get involved. It's not necessarily just writing code. So if you want to come and get involved in the community, please come and say hello. Finally, how do you find out more? Researchplatforms.com, come and swing by our website. We will be doing more tutorials in this series about crawling the web, and also, of course, about a whole bunch of other things as well. So keep checking back at researchplatforms.com. You can obviously find our YouTube channel and subscribe to that. We'll have more and more useful things coming in the not too distant future. If you're interested in the people who actually built this platform from scratch, I would suggest that you have a look at the RDS USC website. There's some useful information there. They're a nice bunch of guys, and there's an awful lot of cool science that comes out of USC. So go and have a look there. And then obviously there's the Git repo again. So if you're interested in helping with development, or if you just want to know more, or if you want to do your own thing with it, the source code is available. It's Apache licensed. You can do whatever you like with it. So that's it. I hope you've had a good time on this webinar. I hope you've learned a thing or two. We're going to stop now for questions, and so if anyone has any questions, please fire away. Oops, sorry about that. There we go. I pushed the wrong button. So one of the questions that I get asked pretty regularly is it legal? And the answer is it depends on the website. It's not depending on the T's and C's, the website, the web service. If you're breaking their terms and conditions, then of course it's not legal. So you have to be wary about what you're trying to crawl and what you're trying to achieve, and work with the ethics that are intertwined there. So I advise that everyone takes it with a pinch of salt. And if you're not entirely sure about its legalities, then possibly contemplate. There we go. That's better. Find a camera, it works. Possibly contemplate not crawling that website. But there's plenty of websites that it would be legal, and so. Just use your judgment when it comes to crawling websites, and go from there. Of course, you can crawl your own. So you might use crawlers for doing internal bits and pieces. Like we were talking about search indexes earlier. Or crawling through a whole bunch of intranet portal information that would otherwise not get collated cleanly. Or creating like a work knowledge base and that type of stuff. You can do that type of thing perfectly legally. But when it comes to crawling LinkedIn, for example, they probably won't be overly impressed about what you're trying to achieve. So just take it all one step at a time, and if someone tells you off, then apologize for it. So there we go. I hope you found the webinar useful. Sorry about the hiccup there with the camera at the end. It's not playing ball today. And that you will tune in. We've got some more crawling stuff coming in the not too distant future around more in-depth deployment techniques, how to deploy it into a Spark cluster, how to extend it, and other crawlers that are out there. So keep coming back. We've got some big data stuff coming as well. So keep checking back for different research platforms, tutorials, and thanks for watching. Hi.